Would you like to tell us how you figured out to take your degree in physics?
Well, I had enrolled into the Institute of Technology, into the electrical engineering degree, because I had my amateur radio license for a couple of years in high school. And that was a natural extension of what to do. One of the courses that we had to take was the beginning physics course, but we had physics courses for 2 years. All of the Institute of Technology degrees had 2 years, or at least a year and a half of physics. And in the fall of the second year, I had Dr. Winkler for that course, and about halfway through the course, he asked for 10 of us to come up to the front of the class afterwards, and it was a class of 500 or 400, something like that, one of these big classes. And he told us that we were the top students in that class and we might like to look into doing physics as a career. So I went to Eddy Hall, where the student counseling was, and read what electrical engineers did, and then I read what physics people did. And I said, oh, this physics is a lot more interesting. I'm not really interested in designing power lines or house wiring or things like that. All this physics stuff sounds a lot more interesting. So it turned out that the prerequisites were identical for the two courses, so I just changed the name on the paper and I was in physics.
During your undergraduate years, you had some jobs. In fact, you worked in a medically related situation. Could you tell us about that?
Yes. Coming from a teacher's family, we never had all that much money, and I was looking for a way to earn money, and found out that it was possible to get an undergraduate thing. Usually, as an undergraduate, you were a lab assistant, in which you went to a laboratory which was run by a staff person, and you collected all the reports and graded them and brought them back to the next one. But about that time, they began to notice that I had a technical background being in an amateur radio and understood electronics. And there's a lot of electronics going on in the physics building. Eventually I got switched over to an assistant for the research labs instead. And it started out by doing the grunt work on running a mass spectrometer on many different samples. Mass spectrometers were rather new instruments in those days, or rather high tech. The one that I remember the clearest was that the medical school could use heavy water to figure out what the water reservoirs were in the various organs and whatnot they were working with by putting in a given amount of heavy water and then taking a sample out later and finding out what the ratio of normal to heavy water was, and that told them the volume. And they could tell how the water diffused into other places and things like that. Well, they had reduced this down to a little production line. They had a little tray which had a dozen slots in it, and each slot had a three-way valve which had a fitting for a ground glass vacuum seal, and on the other side a little glass bulb. And we were set up so we could take one of these things and put it in a vacuum manifold and pump it out and put the little bulb in a solution of alcohol and dry ice and freeze the water that was in there. And then we could turn off the pumping on the other side and flip this little three-way valve so that the hydrogen that was over the frozen water could come out into the manifold, and we fed this into the mass spectrometer and got the ratio of hydrogen to deuterium, and which, I don't know, probably took 2 or 3 minutes per sample. Mm-hmm. And so we ran a dozen of these, and we were producing charts off the old Leeds and Northrop strip chart recorders that were a foot wide, and we would get a couple signals on there, and then we would get a few inches for each sample, and then we would run through all the samples and then take this strip chart and measure the heights of the lines off zero and get a number which we could assign to each sample and bring it back to the medical department. Mm-hmm. And they were very happy. In fact, they invited me to a colloquium once that they were presenting what they were doing with it, and it was really fascinating stuff, but way over my medical head.
And you were an undergraduate. And
yes.
Didn't this lead to your choice of a master's degree focus?
Well, working with the mass spectrometers did, yes, because that was just, Dr. Nier was Mr. Spectrometer, and he had lots of different mass spectrometers in the building, and so I worked on several different ones. Another project which I had was helping a visiting German professor, I wish I could remember his name, in which we measured the strontium to rubidium ratio in the rocks from the North Shore to get how many billion years old they were. and they then got the history of what went on along the North Shore. And that was a completely different arrangement, though, because they had to grind up the rock and dissolve the rubidium and strontium and put it in a little solution that they would put on a tantalum ribbon and dry off, and we would put that ribbon inside the mass spectrometer and heat it up, and the part of what came off was in ions, and then we would measure the rubidium to strontium ratio of those ions. And
this is very labor intensive, isn't it?
Yes, yes.
Yeah.
One had to be very careful that you did these things just right.
Did you also use computers or watch them being used during this period?
Well, as an undergraduate, they didn't. The University of Minnesota did not have a big computer yet. I think they got it during my senior year or close to that, because I didn't really realize that it was there to be used by students until I was in my master's program. When I went into the master's degree, which was trying to use a new thing which was in accelerators called weak focusing, and to see if that could be applied to the ion sources for mass spectrometers. The way you calculated what weak focusing was going to do was through matrix multiplications. And so there was a lot of matrix work to figure out how things did. And you can do this by hand quite nicely, but as you take different arrangements and change the numbers slightly and do it all over again, it soon becomes rather tiring. However, if you could you could make the computer do the same thing with the computer program and have an input deck that would be the new numbers you were interested in, and bring that over, and it would come out with the final numbers without making mistakes. And that was critical, that you, because when you're multiplying the matrices through and everything, and you've got your calculator and you're writing down your numbers, and there's always a chance you're going to make a bad mistake.
So they let you in on the computer deal. And who were the heavy users other than you?
Well, I was a trivially light user. The heavy users were in the physics theory department. And they, in fact, were so enthusiastic about getting their own computer in their eyes, that they actually worked with control data to get a better Fortran compiler and eliminated mistakes that were in the compiler. And so we had one of the best up-to-date Fortran operating deals in the nation. And that was really nice, because we could depend on getting good numbers done.
Mm-hmm. So your master's degree thesis actually used computer?
Slightly, not. Mm-hmm. It was kind of in support of it. The real guts of the thesis was to actually build a source which used the weak focusing and show that it worked, and how well it worked, and what kind of results you can expect to get out of it. And they weren't as good as they had been hoping, and it was rather took up a lot of space and was a little difficult to build and stuff. So it was, I've never heard of anybody using it after that.